Hi, my name is Cameron Thompson, and I decided to do my paper on the Airbus A321LR. JetBlue, as of April 28th of 2021, has began to implement their first A321LR. It includes a couple cool features that I like, which is one of them being the LED mood lighting that changes during the different phases of the flight to reduce jet lag for the passengers as well as the pilots. There are also fewer seats in the cabins, which means there are more room for each passenger. This is just a quick view of what JetBlue has posted on what some of their seating is going to look like. So NASA and Pratt and Whitney geared turbofan have come together to work on the geared turbofan engine for the LR version. They implement a revolutionary geared turbofan technology that includes advances in aerodynamics, lightweight materials, and other technology improvements. So if you look at the graph over here, as the diameter of the fan increases and the bypass ratio increases as well, the overall noise of the aircraft goes down, and the fuel burn is more efficient, and it's at its low point right here with the geared turbofan, so that'd be its greatest point. And so, yeah, that's for that. All right, and then the higher the bypass ratio is, the more efficient the engine will be. And as the bypass ratio increases, the carbon dioxide and nitrogen oxide emissions are reduced, as well as there is a reduction in the fuel consumption and cost. So if you look over here, as the bypass ratio is getting higher and higher, you just see this constant lowering of the fuel consumption and all these nitrogen oxide and the cost, which is really good for an airline company. Now the range, whenever Airbus first introduced the A321LR, it began by having 4,000 nautical miles of range, but with more improvements that they made, they were able to extend the range by 700 nautical miles. So the current versions can travel up to 4,700 nautical miles. The Pratt & Whitney geared turbofan engine has a bypass ratio of 12.5 to 1. It has an 81-inch diameter fan that moves 40% slower than previous generations, while its core is still very fast. This allows the engine to work at peak performance with no compromises, while each part runs at its optimum speed. And the way that the fan can go at a different speed than the core is by a fan drive gear system that implements a 3-to-1 gear ratio. This controls the speed of the fan, so you can more efficiently control the speed, the overall performance of the engine. Pratt & Whitney also eliminated 2,000 airfoils from their previous generations, and with all these improvements, there's been a 16% reduction in fuel consumption, 75% reduction in noise footprint, and 50% reduction in nitrogen oxide emissions. The engine compressors have a 60% higher pressure ratio compared to previous generation engines and contain fewer stages when compressing. The engine shares the load effectively between its high and low pressure spools. The Pratt & Whitney engine has up to four fewer turbine engines compared to current generations. And each engine weighs about 6,300 pounds and can deliver 24 to 33,000 pounds of thrust. The Pratt & Whitney geared turbofan engine also has used the Collins Aerospace nacelle systems, which they introduced small hole perforations on the inlets and thrust reversers to reduce aerodynamic drag and improve noise attenuation. The exhaust system is made of titanium inconel or ceramic matrix composites to help with noise reduction. And the inlet also implements a patented aluminum deep draw lip skin that enables natural laminar flow with no split lines. All right, and that's the A321 for you.